Hi, welcome. My name's Oak. I'm a scientist at Columbia. I'm located here at GA. The goal of today is not to teach you about a module. So if you're here to learn about a module, I'm sorry. Today we're going to learn how to use modules in the sense of like, what do I do with OMFIT to answer a physics problem? I think one of the biggest complaints I hear about OMFIT is really great if there's a set of tools that are designed to do exactly what you want to do, and then you can use those tools. And then if you can't use those tools, and the tools want to do something slightly different, then it becomes a little harder. 95% of research is unique stuff, right? You're answering problems no one's thought of before. And so very often you'll encounter problems in OMFIT that are not necessarily directly coded up in a module already, or maybe they use parts of one module and different parts of another module, or maybe you just want access to the Python tools. So I wanted to give some sort of loose tutorial, and feel free to ask questions as we go, that really just talks about like how would I actually use a module to do a research problem. I think the font is still a little small here for the people in the room, so let's try to make it a little bigger. Let me know if this is any better. Is that readable in the back? Yeah. We'll go up to 15. Cool. So in order to demonstrate how to use OMFIT to solve a problem, we're actually going to solve a problem today. So the D3D tokamak is planning a diverter upgrade for negative triangularity in the coming years. And one of the things we have to know about the diverter upgrade for negative triangularity is the shapes that we want to make going to be able to access H mode or not. And in negative triangularity, we think that H mode axis is controlled by the ballooning stability limit. And there's this module in OMFIT called BALOO, which you can use to look at the ballooning stability limit. We also have in OMFIT the ability to look at G-codiscs, which are the shapes, the magnetic shapes we want to use. And so the goal today is we're going to load in a bunch of shapes from this new design. We're going to run them through BALOO and see if they work or not. And then we'll encounter different issues along the way and how to deal with them. So I do already have, let me just copy this directory over from here. You can see I'm not starting exactly from scratch. Oops, wrong button. So I do already have a few, so we already have the equidiscs. We'll type it up by hand. So this is one common problem you might get in OMFIT is copying stuff from one window to another. Yeah. So sometimes if I say paste, it pastes something that's not actually in my computer, right? So you can see what I'm trying to do with my hands. We can do it this way. This is really an OMFIT issue instead of, sorry, a no machine issue instead of an OMFIT issue. And so it's not really OMFIT's fault, but there are workarounds that we can do. One of them is saving something to the tree. So if I save just a test script to the tree here, this is an empty Python file. And then if I go back to here and I copy it from here, sometimes this works. So let's try that. Look at that. I was able to do that. So I copied and pasted and loaded from the tree. Now I have all this text that I wanted, which is really, I just wanted this directory so I didn't get the wrong spot. So we have a bunch of directories in this location. This is where my G-codiscs are stored. How do I get those into OMFIT? Before I do anything, I actually want to back up a bit and talk about structure. So very often in OMFIT, especially if you're planning on using a project for a long time, your structure can get quite chaotic, i.e. here's a module I'm using. You can see I have tons of tabs. I don't know what's going on in which one. I have lots of subfolders here with other subfolders and other things in them. And this is a project I've been working on for several years, just as like a database to hold. It's an absolute mess. So whenever you're starting a new project, I like to start off by trying to organize it as much as possible. So I'm going to have to write some scripts in this project. So I'm just going to make an OMFIT tree called scripts. This is just a folder. It's a folder here that I can put my scripts in. I'm also going to know that I'm going to make some plots. So I'm just going to make a plot. I know that I'm going to load some G files. So let's make something called G files. And if we need more, we'll make them later. But these are just literally folders on your desktop. You can think of them that way. in OMFIT that we can place our scripts. So this first script I already have written, and this is, again, I want to take some equilibria and load it into OMFIT. The first parts of this are pretty simple. First, I don't want to override anything, so I mean, I guess I already did this. You can delete this, but I wanted to make a folder that I could put my G files in. So I'm just going to say, if there's no folder named OMFIT, or named G files in OMFIT keys, let's make a folder named G files and let's make OMFIT tree. And so this, if I run just as part of the code, will make a G files folder, right? And then if I do it again, it doesn't overwrite that folder. So this way, if I save data in there, right, I'm never going to have to worry about getting rid of it. I also am thinking ahead here a little bit. I know I'm going to need different versions of these equilibria. So I'm actually going to make a subfolder within the G-Equidus folder called raw. It's the same thing, just looking for keys within G files. And I'm going to make something called raw, which is a new folder there. So now we see we have our folder raw. And then this is the part that's actually a little interesting. I know I have my equilibria saved here. And so if we went to this directory, we would see a bunch of G-Equidiscs saved in that directory. I want to load those into OMFIT. This is capable with a certain command, but let's say I didn't know exactly what that command was. How would I find out how to load this in? If you go to edit, you can edit these tree entries, and there's different options here. You can do browse, you can do guided, you can do advanced. They all have different sorts of things. If you're an advanced user, maybe you'll use the advanced tab. Say I don't really know what I'm doing. Let's use a guided tab. Let's have OMFIT guide me through what I'm doing. I want to edit something here. Let's call it a test, G-test, or test G-Equidisc. I can select what type of thing this is. Is it an OMFIT tree? No. Is it an MDS plus value? We talked about these a couple weeks ago. No. This is an equidisc. It's a G-Equidisc. So I can go and I can look on my files here for G-Equidisc. I'm sure I have one somewhere. This is for ARC. So here's an ARC G-Equidisc. And I can OMFIT G-Equidisc, load it in here. I'm actually just going to copy this and paste it in the command box for future use. But if I just hit enter here, it will give me a character under because I have a divide sign. But it will load this G-Equidisc into this raw folder, right? I now have my whole G-Equidisc information. I can double click it to see a picture. I can press the space bar and it will open up the raw file. So this is the G-Equidisc file, right? We loaded it into OMFIT. I don't want this one. It's not what we're looking at, so I'm going to get rid of it. You see I copied this command into the command box because I just want to show you how we can do this in a script. Same thing, right? This syntax is basically the same syntax as I have already in my code. OMFIT G-Equidisc equals OMFIT G-Equidisc, and then a directory plus the file. The directory I have hard-coded because that's where I save my stuff. And the G file is just a for loop getting the stuff that's in that directory, right? So I know this directory just has the G files in it. And so when I run this, it'll load all the G files in that directory. Huzzah, right? First step of trying to do this problem is done. And I haven't even opened a module yet, right? So you can see we have different versions of a negative triangular shape here for the D3D tokamak. And the goal here is to understand what these different H modes will be. At this point, the stuff that's saved is kind of done, right? Now we have to do physics. And so to do physics, I'm going to have to open up a module. And this is a lot of the stuff we've talked about day in, day out, what types of modules we can use. So here are the different modules that are available, right? There's lots of different physics codes. There will not ever be tutorials on all of these. Some of them have tutorials online and docs. Some of them just are blank, right? And it's important to be able to know how to understand them without the tutorial. One of the ones that doesn't have a lot of tutorials is this blue one, which is the one I said I was going to use. So I'm going to load that in, and then we can just take a look and try to intuit how it works through the GUI. Luckily, this is a very simple module, so it'll be quite easy to do. But I opened up, or I loaded this blue GUI. It has some input file, right, which looks like some basic. It doesn't have anything outputs. Has one or two scripts, one plot, one GUI. So very simple module, a good one to tutorial with. If I open it up, this is what it looks like. It gives me two commands. It says pick a G-Equidisc. Okay, pick it. And then run blue. Great. Let's see what happens when I click that button. So another button popped up here. It says, it looks like something happened, something finished. What it's actually doing is it's writing everything to a different directory, and then it's calling some code here. So it's doing a local execute of module load elite, and then it's running blue on this G file, which came from my tree. And then apparently this blue code that's on the server, right, is the blue code that's actually running. So the OMFIT module here is just a wrapper for some other script somewhere else. But we can think of OMFIT module kind of just like a Python package as well. Like it comes packaged with ways to look at the outputs and ways to scripts. For example, if I plot this plot stability script, I get something kind of ugly, and it's a physics result, right? We can interpret what this means. The x-axis here is the normalized radius. This blue line is the experimental alpha. Alpha is the normalized gradient, and this red line is a boundary condition that it finds. So it looks like it's not really seeing much of a gradient here in the edge, and it has some boundary condition, and maybe they're matching up. I don't want to interpret the physics of this, just showing it as an example. Cool, I did that once. I have 5 files in this. You can imagine scenarios where you want to do this for thousands of files, or you want to run cgyro for hundreds of files, right? And so you don't want to have to do stuff manually every single time. And if there's some way to sort of organize things, then you can do it automatically. So what we're going to do is we're going to try to write a script here for demonstration purposes that will automatically do the blue analysis for us, right? The blue analysis was very simple, and so it should be a simple script, which is good for tutorials. So I'm going to, well, before I do this, let's actually use my scripts tree to keep my command box. So I'm going to save this to tree. This was load all. Cool. So now I have a script here, which is load all. And it's just going to stay there, so I can clear this without worrying about it. What else do I have? Nothing. Great. So let's do a new script. Let's call run blue. How do we figure out how to write a script that interacts with the module? The first thing that I like to do is get the module itself. So I'm just going to define blue as OMFIT blue. This is really just renaming something in Python, but sometimes you have something with very long dictionary after it, and it's just nice to give it a short, simple name. And so you can keep track of it easier. Or I'll have multiple different blue modules in my code with different settings in them or something, and I want to be able to pick between them. So good to do this. And then what do I want to do? I want to run this for all of the equidiscs. So let's start off by getting a for loop going that has each of these equidiscs in them. So for key in, and I'm going to copy this keys, right? So this will give me, I can just print key here to show you what it's going to do. This will give me all of these different keys that are in my gequidisc file. And then how's this going to work? Let's see, blue has some output here. So I probably need somewhere to store the outputs of this module that I'm going to run. So I'm actually just going to quickly go over and make a spot. We'll call it blue out equals OMFIT tree. Make a new folder here, which is currently empty, where I can potentially copy over outputs. So first I'm going to say, okay, look at the outputs. They have a couple different outputs in here, right? So why don't we just copy the whole output tree? If we haven't run this code already, again, we don't want to overwrite stuff. So if key not in blue out, right? If I don't have outputs for this key yet, let's just make a folder for this key. So now we have blue out key equals OMFIT tree. All this is going to do is make some folders down here. We're expecting output for a different equilibrium, right? It's keeping it nice and organized so that I can come back to this later and know what I did. We also have to actually run blue, right? And we're going to run blue for each of these keys. So I can stay in the same for loop here. And how did we do the blue module? So the best way to figure out how to optimize a code is actually just go back, or how to automatically run something that might be in a module, to go back to the module and track through it manually. So if we remember, we started with this pick an equidisc thing. And if we look at our inputs, I can right click on this and it will show me, so if this is a right click, it will show me where in the tree it's supposed to be storing this equilibrium. So it's saying pick equidisc is going to put something in blue inputs to equidisc. Right now there's nothing selected there, and there's no GQDisc output, right? If I wanted to actually take this action and load a GQDisc, so I can do that manually in the GUI and see what happens. So we're going to load this. Look, it populated. So it seems all I have to do to set up the module to run, and other modules will of course be more complicated, is copy over the GQDisc into this inputs folder. So what I can do now is, let's say if, yeah, so let's just go copy. So I want something here. So this is where I want to put it. So copy.deepCopy is what I always use. Sometimes you just copy or you say equals to, and Python does its thing where it assigns the same thing to the same variable, and then you edit one and the other one gets edited and you get all confused. I got tired of figuring out when to use what, and so I just always use copy.deepCopy. There are other offlins. You can use .duplicate as well. There's several options to do this within the OMFIT framework and find out which ones use the best for you. I think Joey was going to tell me to use .duplicate, but we can do that. Yeah.
When should we use .duplicate versus copy versus deep copy?
Copy.deep-copy takes the dictionary as it exists in memory and does a deep copy of all the dictionary elements. But it may not change the .filename attribute. And so it's unlikely that you could get a conflict, but when you have two files in OMFIT with the exact same .filename, then you could get some weird stuff on disk. So anytime you have an OMFIT object, I would recommend a .duplicate.
Sterling says we're doing .duplicate. There we go. What is this going to do? It's going to copy over this particular file into GQDisc, right? I don't want that. I want a different one every time. So we'll do this. So if I just run this, it's going to run through, and eventually it has the last GQDisc, right? This 351.014.1141 is right here, right? So just copy them all over to the inputs. That's all it did. That wasn't all we needed to do for the blue objects, right? We also need to click this big button that says run blue. So in order to figure out how to run this script, again, I can click the right button. When I click the right button, it's bringing up this, or so the right mouse button, it's bringing up this example in the blue called scripts run blue, which is this script here. So I can copy this over to here, and I can say .run, and that should run the thing. So if we do this, now we can see it copied over a certain one and it's running. It looks like it's doing something. Blue is very quick, so I'm not too scared of this, but say we want to stop it, we're just testing this, say abort, we're all good. I get scared often that I'll put in an input and it won't like completely clear the OMFIT module or something like that, and I'll end up copying something that's wrong. So I like to, in scripts like this, just put a blue, or why am I doing .blue, right? We have this shortcut. We already defined blue as an object here, so make it a little simpler. I like to clear the outputs beforehand, just in case something would go wrong, then I don't copy something from before. So I think that's a good practice to get into. And we can even, yeah, so we're copying our inputs over, we got our outputs cleared, we're gonna run blue, and then the final thing we have to do, right, is take our outputs and store them somewhere. In the blue case, we're gonna do this with this dictionary that we built here, blue out, right? So I'm gonna just say blue out, right? Copy and paste this over from here. And then this is our key that we're running, right? This is equal to copy.deepCopy of the outputs. So what should this do? Set up our module, make sure that there's nothing conflicting in the outputs that will accidentally copy over later. Run the code, right? And copy the outputs over into a folder. That seems good. So I'm going to save this as run
to duplicate
blue. Huh?
You want to change it to duplicate?
We're going to show that both work.
Okay.
We'll keep one and the other. Yeah, so I can either hit execute here, or I can just double click on the script in the tree. And now we're going to do all this physics analysis that would have taken us 10,000 button clicks to do ourselves. Just with one button, right? The code's running for us. It's going to run the same analysis on a bunch of different inputs and store those outputs in a folder. And so you can see now it's done. That didn't take too long. I'm going to save this now because we have some data and I don't want to lose it. So tutorial, see if I can spell. In our GQuitis or in our outputs now, each of these trees looks like one of the outputs trees from OMFIT or from Baloo, right? So we have a bunch of physics results from our physics input. Question?
So if now you edit on that command area, is that automatically saved into the script that is saved, or you need to save every time that you want to update?
Good question. So let's put a test edit in here. I think if I try to execute this, it'll say that's an invalid syntax. If I go back up to this file and I press space bar, it's not in here. So this got saved as a new Python task. I can load it back from the tree, load from tree, and then that edit disappears. So this is a good way also to like just kind of version control yourself. So often when I'm writing a command box script or trying to develop something that will be quite long, right? Longer than these 6 lines, I'll save a version every time like a chunk is done. It's kind of like a commit on GitHub, right? It's just an internal save, and it's a nice way to keep track of work. Cool. So nice. I have some things. They are weird looking files. They are data type OMFIT ball stab, OMFIT outball, OMFIT ASCII. This isn't really useful to me. It's a bunch of files, right? OMFIT parsed them, but they're hard to use just as the files themselves. How do I learn how to use these outputs? Well, guess what? The module had a plotting script, right? So we can go and look at that plotting script to figure out how to look at what's inside these weird OMFIT ball stab objects. So I save this, I can clear it. For visibility, I'm gonna go to this plotting script, right? When we went here and we plotted stability, this is a button we wanna look. Again, if I right click, it tells me it's this particular script. So if you have a more complicated module, you can find out what script you're interested in reproducing that way. So here's our plot script. I'm gonna load it from the tree. And you can see it's some complicated parsing, right, of the output, right? This will look like it takes. No, it's a good opportunity to talk about what root means. So if I try to run this here, it'll say, "Hey, you have a key error inputs." Why is that? Root is a very common tool we use in OMFIT. It's very similar in principle to what I tried to do in this module where I say Baloo equals this, right? It's basically just giving the code a reference to wherever you are in your file structure. So in this case, it was loaded from a module. The root refers to the base module that it's in. So in this case, it'd just be OMFIT Baloo. And I can actually change that namespace. So I can go say, okay, hey, OMFIT, I don't want to run my command box anymore from OMFIT. I want to run it from OMFIT Baloo. And now root will no longer be OMFIT, it'll be OMFIT Baloo. So root gets replaced by basically whatever up here in this namespace. So if I execute it now, we'll have our plot, right? And again, we have our normalized pressure gradient and some stability thing on the x-axis or on the y-axis here. Whoops. Cool. So what is going on here, right? This is some parsing. It's getting something from the inval. It's getting something from the outval file. So it's using the inputs. It's using the outputs. It's also getting something from the ball stab file, and it's putting it all together in a plot. You can go through and identify line all these are. That takes a little second. So I just wanted to do that off screen. And then I have this thing called multi-plot Baloo, which the goal is I want to be able to plot all of my things together, not just one at a time. And so you can see this is a very similar script, right? It looks about the same. I didn't change the back end here where it's finding these Y1s, X1s. I didn't do much to anything. What I did do is we compare these two, right? I added a little bit of description of what these default var parameters are. And then I added this default vars, which Quinn talked about as well. This is basically like a function with some inputs, right? And you can see these inputs. I have a Baloo module. I have a location of results tree, right? So I wrote this script to be able to interact with this results tree that I made. So I'm modifying basically the plotting script within OMFIT and using that plotting script to work with something grander than is in the module itself, right? And if I was a really, really awesome person, I might go back and push this to GitHub so that other people could use it, right? Sometimes you have the time for that, and it's awesome. Sometimes you don't, in which case you just keep it private and do what you do. You can also see I just added some other keys here, which let me shade things or change my plot in certain ways, right? And so let's see, if I just go back to my OMFIT namespace here, and then let's look at what we've got. Oh yeah, so I wrote this and I forgot to do something live. That's okay. It'll teach us a thing. So this was supposed to work exactly with what is written, right? My blue module is here. We need this because we need the inputs tree. I didn't want to copy it over. I could have copied it over somewhere else, right? My inputs are changing, but I didn't. I have a results tree, which is where I stored all my things, except it's actually not. It's OMFIT blue raw. If you remember back here, I saved my G files as raw. I was intending to also save my outputs as raw, which I didn't do. So we can go fix that real quick. Either we could change this to blue outputs, or we could go in here, we could make an OMFIT tree, right? And then there's a couple ways to move it. I could do it with a script, or I can go over here and with a right arrow, I can say move, rename, which is, I guess, what I'll just do. And then I can add a little directory here and it'll move that over to the raw, which is great. So I'm just going to do that 5 times because it shouldn't take too long. But we could have easily written a script to do this or done in any other manner of ways. And this is just setting up for something that we'll have to do shortly. Cool. So now we have all of our outputs in this raw thing. I am going to go back and just change this here, right? So we have a raw, or let me do it in the bigger screen so you can see. So I'm going to go back and edit my script that did this. I really want, like, I don't know, let's call this a run ID. And run ID equals raw up top. And then we'll do something similar to this. So if key not in run ID dot keys. So if we haven't run it already, run the thing. Oops. And then I will just go to save this back to the tree so we can use it later and then get rid of it. So now if I run this, it should work. So really, this is the same plotting script we had before. Now it just has 5 lines on it, right? Very simple improvement, but it shows how you can take something that exists in OMFIT that doesn't do what you want it to do, and then change it into something that you do, that does do what you want it to do, right? So you can go beyond what the module itself has. These are really just like, you can think of a module as like as a Python class, right? It provides you some tools, and you can go and edit those tools or use those tools in different ways to come up with some research project you want. Neat. Let's save this in the plots tree because we can. Multi-plot blue. So at this point, I'm looking at my outputs. I think, okay, I've done some stuff. I think I can just go and run this again. It looks like I ran the module and I got some physics results. Knowing the physics that I need to know to understand and do this project, right? What I'm actually interested in is, can we build a gradient in the edge? And sometimes when you build a gradient, the stability changes. So how am I supposed to do that with these G-equidiscs that I was given without a gradient, right? These are like EFIT01 G-equidiscs. They don't have any kinetic profiles. They're just shapes. And so how am I supposed to test if they have a gradient in them? I need equidiscs with gradients in them. There are a ton of different ways to get G-equilibrium files with gradients in them. You could make a kinetic EFIT. You could do whatever you want. I want to use a module called Procreate, which is another one I know about from talking to experts around GA. They were like, hey, here's a module that does a thing. Or conversely, I could have said, here's one I know about by Google searching on the OMFIT modules page to look for tools that were available, right? My goal here is to add a gradient to an equilibrium. Lots of ways to do that. Here's one. So I'm going to load in this OMFIT Procreate tool, and we'll open it up just to take a look at it. There is a tutorial for this tool online that's pretty good. So I highly recommend you go and check that out if you want to know how this works. I'm not going to explain what every detail about that is here. I'm just going to use the module as a user. And so we can talk about how to edit it and do different parts. So I am going to start from an input G-equidisc, right? I have some G file that I want. And I always, before I automate something, I always like to do it manually first. So let's just take this equilibrium, load it in. I'm not going to worry about anything up here. I would like to add profiles to this equilibrium that are H mode-like profiles. And I would like to set, I don't know, the pedestal temperature to be 0.3, pedestal density to be 0.5, just to show I can change these numbers. It's a GA equilibrium, it's a D3D equilibrium, so I can use EFIT. If you're doing this, I loaded an ARC module at the beginning. If you don't have like the ARC screen functions, you can also use other solvers like cheese, right? So basically you're choosing a solver to do what you want to do. And I can try to say run procreate and see what happens. So I'm testing something out before I go and write that script. It looks like it does something just like before with Baloo. It's calling some other scripts locally. So it's putting some G-Codisk information somewhere, and it's running some stuff. It's calling this code, which exists. I've never looked at this code. Don't know what it does. I assume it runs EFIT. Because at the end of the day, Procreate made some things. And I can say plot equilibrium. Look at that. So I have my original equilibrium, which didn't have a nice pressure profile. And then Procreate has resolved an equilibrium for it with a pressure gradient in the edge, right? Which is ultimately what I'm interested in. I'm interested in, can these things be H mode? Cool. And you can see there's lots of different options here. So there's different variations of Procreate that I could think about running. Again, let's pretend I have 500 cases. I don't want to go through and run Procreate manually for 500 cases and make sure I get all the settings right for each one. So what I'd like to do now is automate another module and link it up to this old module that we have. We already went through how to write the module, so I'm just going to take this from my test folder right here, see if the copy paste works. Probably won't. When it doesn't, I'll demonstrate a different way to get scripts across. So I can save, one thing I do a lot is I save my scripts to a file. So this is script 5, just in my temp directory. And then I can go over here and I can load from file and load up script 5. Same copy paste, just a different format. Yeah.
This may be a dumb question, but you said that you ran Procreate so you could see if this could be an H mode. I think the logic there is that you have two different fits, and one fit assumes that you have a pedestal, and then you look at it and you see it, you make a determination on
Yeah. So
that looks acceptable. Like what's your judgment?
So yeah, maybe I misspoke a little bit. So my goal of this whole project is to see if this will be in H mode or not. In order to do that, I need Baloo. But the input G-Codisks that I was given aren't good enough to make that determination themselves because they're not kinetic equilibrium, right? And this is an imaginary shape that doesn't exist yet. So I need a way to fake a kinetic equilibrium and see how that will influence the stability of the properties with Baloo. So now this is a topic that like cannot be done with a module, right? There's no module in OMFIT that will do this for you. There are modules in OMFIT that will do parts of this for you, right? And so I'm using different modules as like different coding glue to put together a research story, right? I'm going to use Procreate to edit my input files. I'm going to run Baloo on those edited input files and see if the result changes. Yeah. So this is the script I wrote. It's very easy to see exactly the same way how we came up with this, right? So I have some module here. Again, I called it Procreate, just the root sort of flavoring, just to keep this script self-consistent. Everywhere I call Procreate, not OMFIT Procreate. I wanted to be able to run it for different TE and NE, right? I said there are different settings. You can see there's a lot of different settings here, but let's just pick 2 of them, TE ped and NE ped, and see if we can run it for that. And then just like I have the raw OMFIT trees, I want to be able to keep track of these different runs that I do. So I'm using an F string here to make a new tree. And so we can just run this first part like this over here. So I'm using an F string here to make a new tree in my inputs, my G files inputs, that is TE ped, NE ped. So I can just keep track of what runs I do. So this makes a new folder. That's all it does, right? Then is the part where I run Procreate for each of these codes. So for each of the G-Codisks in my raw, right? So I want to transform my raw equidisks into something new. So for each of the input equidisks, I'm going to copy the equidisk over into the inputs for Procreate. We decided earlier that this should be duplicate. So let's do that. Duplicate. Then I wanted to set some settings, right? So how did I find out these were the right places to go? I looked at what I wanted to say. I want to say pedestal temperature. I right clicked and it says, here is the variable in the OMFIT tree that you want to change. So we can go check this out, right? If I go to Procreate, settings, physics, TEPED is a number here somewhere, right here. There are other settings, right? So I could change all of these if I wanted to and do a really robust job, right? I'm just going to change 2 of them, NEPED and TEPED. And then I run Procreate. How do I run this? Well, I want to run this script here. So right click, find the location of that script in the tree. And then I want to copy the outputs, right? So this is all it's going to do is give me my new equilibrium into my tree, right? So I have a new folder where I want to save my equilibrium. And it has a new equilibrium G file, and it's going to copy the outputs from Procreate. Let me turn unwrap so it's a little easier to see here. So this will run Procreate for each one with my new pedestal settings, and then add that new equilibrium to the tree. And then I also have the script run blue all, which is basically, well, this is a different script I wrote, but let's just edit our run blue script. So again, for visibility, I'm just going to copy this run blue script over here. Because once I have the equals, I already have the script that automatically does blue, right? So why not just call that at the end of my script that runs the equilibrium? So I can run this from over here. It's going to run on some run ID, right? So we can now, if we want to make this into a script that will run, we can change this and going to copy this over. I want to make this an input file, right? So I'm going to have this like default vars sort of syntax. And I just want run ID to be the only thing that I can change. So now it will, if run ID is not given, it will take run ID equals raw and run on the raw tree. But I could also give it a new run ID and run it on that. So I'm going to save this back to run blue. Save to tree. Go over here. And then this is not run blue all, it's run blue. And I had run ID equals, and this is where this is all the stuff that's in there. Oops, what? And I think probably there will be a bug, since I know a little bit about how this is going to work. If we look back at the run blue file, it's assuming that this equilibrium ID exists in outputs, right? It says, oops. I didn't even do it right. I need to save it in the particular tree, right? So it's assuming that that tree works and exists in the output, but it's not. So we can just add another one of these little scripts that say, okay, if my run ID folder does not exist in blue out.keys, yeah, well, that's exactly what I typed up here. Then run ID does not exist in blue out.keys, then make this run ID tree. Run ID tree, so that it will make the tree so that I can populate it later. So I think that's just a small bug trick we have to. It's always hard to code while you talk. Yeah, question.
Yeah, well, actually, commenting, sorry.
Comment.
So the last bit you did, the like, if this not in that, then make it an empty tree. So you could, OMFIT has dot set default.
Yeah.
So yeah, if you, and that'll also return the location. So like that first if statement, people were typing that so many times, they just made dot set default.
Yeah. And
then you give it the name and then the object that you want to set default if it doesn't exist. But if
So
it does
what is-
exist, it'll return the object.
Yeah. What is this? It's a capital D, right?
No, lowercase, it's
Lower-
a method
It's a method of
of OMFIT object.
all Python dictionaries.
Oh, never mind, JK.
So yeah, so there's this set default thing that you can use as well. Just like with copy.deep copy and duplicate and copy paste and save to file, right? There's OMFIT is a whole ecosystem. There's lots of ways to do it. Yeah, I write the if thing every time because I'm lazy, or maybe because I'm not, I don't know. It's probably easier to do it this way, right? But
There's one case in which you don't want to use set default, and that's if the default value is something that takes a long time to create,
oh yeah, sure.
or you don't want to create it.
Yeah, but yeah, so there's ways to do it. Highly recommend the set default. It'll probably save you keystrokes in the long run. Thanks, Glenn. Yeah, and again, we looked for that just by searching for it, and it will give you the source code. It'll give you what it's supposed to do, and so you can update your scripts that way. This will take a sec, so I'm just gonna execute this. Hopefully it will run. Maybe we have some bugs. Looks like it's going. It's doing something. So it's running our first iteration of Procreate, adding in those profiles.
That last line.
I probably could have, but I don't think I need to. Because what's going to do, so the question is, should this last line be indented? Which means basically put it in the for loop. I don't think I need to in this case because this script that I wrote, run Baloo, already has a for loop in it to do it for all the G files. And so I can just call it once at the end. But I mean, you could, again, do your stuff differently and have something that just runs Baloo for one equidisk and have that equidisk be part of your default vars so that you could call it on specific equilibrium, right? And that's maybe a more flexible script, not relying on having a folder, so there's different ways you can set this up. Yeah, so this will run for a sec. Procreate's a little longer than Baloo. And so you can see, I mean, these are both pretty simple modules. You can see once you get to like other modules, like I've done automation for this for transp, for example, and run hundreds of transp cases with different sets of inputs. Transp takes weeks sometimes, or not weeks, days to run. And so doing that manually is a pain, right? You have to sit at your transp computer, check when the things are done, send off new requests, and then blah, 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 blah. Same thing for other codes that run externally to OMFIT that are long, right? If you just write a script to do it, you press it once, and then come back in a week, and then it's done for you. And that whole other time, you can be doing other things and going surfing and all that. It's nice to have your code running in the background while you're enjoying your life. So let's see, how close are we? We can maybe check our outputs. We still haven't finished one, or we check our, here we go. So first we're making the equilibrium. We finished 5 Procreate runs, and now we're on to the Baloo. We created our folder, right? Our script made our folder for us, and now it's populating that folder with the Baloo outputs. So this whole time when the code was doing hard work, we were just chatting. The script seemed to run. I'm going to save it to the tree. I'm going to call it run new Procreate. And I'm going to save my work. Saving work is very important. Don't forget to save your work. So what did we do? We had some new equilibrium, right? I added a gradient to the edge of each of these equilibrium. And they're now slightly more realistic, right? I faked all this, right? I made up some pedestal, but you can see how you can change your inputs around. You don't have to work within the confines of one module. And then I ran Baloo on all of it, and I got some outputs. So we can go to our multiplot Baloo script. This is saved to tree. I'll clear it. This is saved to tree. I'll clear it. Our multiplot Baloo has a results tree. So I'm going to do this with default vars again. So multiplot Baloo.run results. I don't want to plot the raw anymore. We saw what that looked like. I want to plot this tree. And see what happens. Wow. So what do we got? One, we got an error in one of our things, right? This means, this is exactly why I had those clear outputs, right? So if I didn't clear outputs of something, then maybe I would have just copied over outputs from something else that worked already, and I wouldn't have known that one of my runs failed for some reason. You can go debug this error. It's as straightforward as looking into which one of these things failed, and then go identify that case, look for why it might have failed, put in something to your script to safeguard against that, either a try except statement, or maybe your inputs are slightly wrong, etc. But we did have at least
you also highlight the F6.
Oh yeah, good. So I was asked to highlight F6, which I think I can do on Mac. So this gives you a little what happened. It died, but if you F6, you get more information about that error, and you can go read more about it. And hopefully something in here points you towards that direction, right? In this particular case, it's just I know this error because I ran this code already. It's just one of the equilibrium has an error at the edge, which you can correct in Procreate. We're not going to have time to do that. But the other cases did run. So actually, what we can do, we can demonstrate a little bit of error handling. Okay, I don't have time to go fix the thing that worked for me, but I do have time maybe to make my plot look a little cleaner. So load from tree. I have a for loop in here. for DD key and enumerate results key, right? This is my for loop. I'm plotting each of these equilibrium, and all of the stuff up to the very end here is indented. So I'm just going to say try, and then at the end of my loop here, hopefully no coders get mad at me here, accept, I'm still accept. And any help from the audience? There we go, turned orange. So I'm going to accept exception as exception and print exception. So this is going to skip the plotting, and if I have some bug, it'll skip that. Oh well. Multiplot blue, go back, run multiplot blue. So we skipped that one case that didn't work. We had 4 cases that still worked, right? Which is pretty cool. And you can see now my results look a little different, right? If we ran this for the raw, let's just compare the two. So I have a raw here, and I wonder if my multiplot blue has the ability to make a new figure. Not sure. Can't remember if I did that or not. So let's just do it here. Looks like it did it already. So I had a blank figure there. So raw was the stuff I was given, right? We edited our inputs. We have some change in the physics output, right? And so I mean, maybe this isn't enough to tell us if the diverted campaign for negative triangularity in T3D will go into H1 or not. But you can see how I can use this workflow and keep building on this workflow, keep editing these scripts and use these chunks of modules that aren't together answering this question, but together giving me the tools that I need to be able to explore physics in a new way, right? That hasn't been done before. And that's what this is really all about. So that's kind of what I want to highlight today, right? We have a bunch of tools in OMFIT. Some of them let us access data. Some of them let us run physics modules. Some of them are utility tools like set default and duplicate. And they just let us move stuff around and keep track of things. And you can combine all of those if you're creative into like new workflows that let you do different things. And so, I mean, this is basically all I do all day is write workflows like this. You can see a lot of open workflows. This is one I did this morning where I was generating profiles for a bunch of different cases. So this uses an OMFIT profiles module, which we'll talk about next time. Actually, in this case, I had a whole directory, and I saved different modules with their key title. So these are OMFIT profiles modules. If I open them up, it's an OMFIT profiles GUI, right? And they have different settings on them, which I set in one of these scripts where it changes a bunch of settings. I copy the settings from this EFIT settings name tree I have, and then run it a bunch of times for a bunch of different phases and get a bunch of different outputs. And at the end of the day, I can plot a bunch of different raw fits versus some data for a bunch of different cases, right? And this lets me like work on several things at once instead of having to manually go through and set fits for all of these cases each time, right? I can kind of generate workflows that do this for me. Or this really ugly project that I showed earlier. This is a project that I started in good faith a long time ago. I was like, let's keep track of all the negative triangularity discharges on G3D. And these go back to a long time ago. And so I have here just raw shots. And for each raw shot, their mini proposal number, the list of shots that were in that experiment, right? And I tried to update this as we went along. Those are all fed into the scope module, which Glenn gave us a good overview of. And then scope has a bunch of different tools. So a lot of these are like different tools within scope that are doing different things to my data to make different plots that will go to a paper or we'll go to a presentation, you know, and they're all, this is a really ugly project because it's evolved over 5 years and I didn't know what I was doing when I started it. But you can imagine workflows like this that just give you access to data and you can keep developing them and building them over time. I actually shared this file, this particular project with 3 different scientists at GA, all of which have used it, including Tyler right here, right? So they can then, I don't have to push this to GitHub, it's a mess, but they can still open up my OMFIT project and make their own developments to it, right? And it becomes kind of like a hodgepodge of things and blah, blah, blah. And again, all of this is just going beyond what's actually in the module itself. Yeah, so workflows. Any questions? Yeah.
I have 2 questions. First one is that usually whenever you create some tree, you know, you always create it first empty and then you try to populate it. I guess that you cannot actually create it and populate it in the same command.
I think the set default gets you the closest to this, right? So set default, basically what it does is it says, does this exist? If not, make it this, right? Set a default value for whatever this entry is. So you could, in this particular workflow, right, you could say, does this tree exist? If not, set it as an empty tree. But you could also say, does this setting exist? Set it as a parameter. Does this directory exist? If not, point it here. And so you can create something with an identity already with the set default command.
One layer deep.
Only one layer deep. Yeah.
You can't make it like build a huge.
There are
nested
ways
tree.
to do that too, but you can't populate the end. So,
You have a second
but
question?
that also gets very ugly.
I have been working with files that are saved from Python, so they are .npc or something like that. I have struggled a lot to be able to import them into OMFIT. I am not sure if there is a way, because in general, when you are using the files within tools, they are already very much OMFIT ready. But
Yeah.
I have struggled with
This
that.
is a great question. What happens if I go to edit tree guided or whatever one you want to use and you don't see what you need in this list, right? This is the actual work I was doing for this case instead of the OMFIT tutorial. You can see that's very similar structure. I called things slightly differently. But I have these commands down here, plot growth rates. So these growth rate commands are integers, right? That I load in this load scan file, which loads a text file, which was generated in MATLAB, right? I could also load the .mat file or something. So basically, OMFIT didn't have a tool to calculate. It will this summer. We have a silly student coming to do this, but it doesn't have a tool yet to calculate like really nice growth rates based on the D3D equilibrium, right? So I had to run a different code and a different software, which gave me a .mat file, or it gives you the .mpc file or whatever it is, right? At its heart, OMFIT is still Python. So all I'm doing here, I'm not using, I don't think I'm using a specific, I'm not using a specific OMFIT.mat file or OMFIT.text class or something, right? I'm literally just using open in Python to open my text, do some parsing. And I wrote this text file to be simple to parse, right? But you can do whatever you want. As long as you can read it in Python somehow, you can copy that code over into OMFIT. And so then this lets me get a bunch of data that I generated in MATLAB into OMFIT, which I can then use just to plot growth rates as a function of color, right? And so the data here, the growth rate data was generated in MATLAB. Read that in with Python, because Python can do anything. And then just add it to the tree and continue your day.
But I actually think NPZ files are in the list.
MPZ should be in the list, yeah.
Array file, so you can just load them.
So yeah, you can always search in the help window, MPZ, maybe it's in related. Anyone knows the answer. Sometimes the help's a little hard to use.
All you have to do is load.
I think you can just
Yeah.
load. Yeah.
Just load?
Yeah.
I was looking for the name of the data type, but
Like the binary version of the dictionary.
so does anyone have well, we could demonstrate. If you have an MPZ file on the tree, we can go load it right now, but we don't need to.
My object statement.
Yeah, sure. Any other questions? Yeah,
You've been talking about pushing back to GitHub. Who controls that?
great question. So yeah, there is a team of people that are authorized to make permanent changes to the unstable branch. I'm not a member of that team. So the way that I can contribute to GitHub is, well, I won't demonstrate, but I can go to GitHub and I can make a new branch based off of unstable. And then I can load that into my local directory. So if I'm doing this on Iris, I have this OMFIT source directory in my Iris directory, right? And so this OMFIT source is literally just pulling from GitHub instead of using the module install on Iris, right? And then I can make a new branch, edit whatever changes I want, and then push that branch back to GitHub. It'll stay as a new branch. I have complete control over what happens to my branch. And I have several branches out there that aren't merged into unstable because, for example, they're made for a particular use, which isn't really generally applicable, or made for a particular group. One example is like a module that I wrote to help people understand JRT22 data from a particular framework, right? Which is only useful for like 4 people. It doesn't need to be a general purpose module, but it exists on this branch that they can use. If I wanted to push it back, so for example, like the Rabbit module, I could push it back by opening a pull request to unstable, and then it will get reviewed by this guy over here, that guy over there, and some people that know all the ins and outs of OMFIT to make sure I'm not breaking anything, right, or doing something stupid. And so some expert will go through your pull request and change all the stuff that you might be a little hesitant about. They'll give you feedback and say, hey, you should be using duplicate here instead of copy.deep copy. Or for example, I learned about the fstring command, which is my favorite thing in Python. I learned about it through OMFIT GitHub reviews because I didn't know about it. And then someone was like, you should use an fstring. I was like, wow, that's cool.
I highlight one thing.
Yeah.
You don't necessarily have to create an OMFIT repository locally to be able to.
Sure.
push
Yeah,
content.
yeah, that's true.
If you go through the menu there, the develop, very top,
Oh yeah, cool. I've never looked at this.
and then I can't see it. It is.
Yeah, it's good for modules. So manage module scripts, yeah.
Managed module scripts, yeah. So yeah, I mean, OMFIT also has, I guess we can highlight this a little bit. So it does have a lot of built-in features into the GUI to help you with branches like this.
Yeah, in case you
so-
don't want to be a GitHub guru.
Yeah.
You should be able to use OMFIT, and I'll highlight that next time.
So
So that you can push back to and then have code review, just like you would any other way.
yeah, so let's just highlight this, right? So if say I'm pretty proud of this module or multi-plot blue script, right? It's simple, but it does something effective. I can add this to the module, move, rename. So now we're going to put it in the blue module. Blue plots, multi-plot blue. It's in here, right? It's no longer in this little tree I have. I moved it in here. So it's part of the blue module now in this particular project, right? But I could go and I could export all my modules, and OMFIT has help with this, and it helps you with the GitHub stuff. And so you can say, okay, what branch do I want to start from? Where do I want to go? And eventually, if I work through this workflow, I don't want to go too far because I don't want to make a new branch or anything. But it would highlight, it would bring up a little list, kind of like you have here, that says, hey, this multi-plot blue script is a new script in this module. Is that what you would like to push? And you can make a new branch then directly from OMFIT that then pushes this stuff. So yeah, depending on your workflow, you can do that through OMFIT or through the command line or whatever. Anything else? All right, we're 3 minutes over. Go have fun.
Thank you, everybody.